Hi, good morning. I forgot to put my name. Some of you know me. I am Nadeem. I'm from HFCL. I lead the Wi-Fi product team at HFCL. So moving the focus from home to enterprise, just a quick definition of what we mean by enterprise. Enterprise Wi-Fi is the Wi-Fi networks that are deployed in businesses, hospitals, hospitality, and education campuses, and so on. That's what we categorize as enterprise Wi-Fi. These networks can be as small as a handful of APs. They can grow to thousands of APs. For example, one network that we are currently in the process of deploying will grow to almost 15,000 APs spread all over Delhi, addressing all the campuses of DU. So that's a fairly large enterprise deployment, but typically this would be a few hundreds of APs. Large campuses, maybe tens of APs in smaller campuses. And these are typically managed networks. So there are IT teams which are managing these networks. And the device ecosystem is also slightly, I would say, constrained. It's not as challenging as what previous speaker was talking about, because these devices are provided by the enterprises to their employees. Of course, there are BYOD devices which are brought by employees, but those also typically, are and mobile phones in most scenarios. Use cases are essentially, we are talking about productivity applications, video conferencing, those kind of applications. The set of applications is in some sense, again, limited, not as diverse as you would see in a home environment. Um, the reason why, of course, performance and throughput, capacity, all these are also important for enterprise, because productivity is affected by how good your Wi-Fi is. So, but one area where enterprises pay a lot of attention, when it comes to their network, is security. The reason is because security has both, direct and indirect impacts on the performance of the enterprise, their, business, customer retention, and a whole lot of other things. And increasingly, just like in other areas, we are seeing that the threat vectors are increasing, the diversity of threats, the intensity of threats, and the periodicity at which people are attempting to break into enterprises is growing. And some, as there are very sophisticated ransomware attacks happening today, which are affecting enterprises and corporations, which run for days and weeks and months. There was a recent case where one large retailer in UK, their website, they shut down for months because they were in the grips of a ransomware attack. Then there are, brute force DDoS attacks which try to bring down the network or deny access to the service to people who are trying to access the network. Then you go to plain old password stealing attacks. I think this morning I was reading that people have, it's a sophisticated attack where some specific home camera vendors, people are using their default password and hacking the camera and getting the feeds directed to some, darknet website. So point is that as an enterprise, that the number of threats increases, and that those attacks have tangible impact on the enterprise, both in terms of financial loss, in terms of loss of data, and in terms of the confidence of the customer. For example, if I am a let's say a retailer, and customers depend on that retailer to for certain service, if that service has an outage, then of course the customer confidence will go down. They may switch to another company or another service provider. So the point is that these attacks are having a lot of impact on businesses, and that's why it is important for enterprises to have secure access to the network. So in the older days, because everything was wired, it was easier to control access to the network. But as we move to a almost wireless only enterprise world, the challenge is greater, because you have all kinds of devices connecting, all kinds of issues coming because of that. So what enterprises are looking for is, one is, I think in the legal world there is a principle that innocent until proven guilty. In the enterprises, it is the other way around. Anybody who connects is treated as unknown until the trust relationship is established. So that's what we mean by zero trust. Until you are able to validate the user and the device through which the user is trying to connect, you don't want to give any kind of access to that user, right? So that's the first principle. Second is user should be able to access only those services or those part of the network which are essential for that user. So if it, let's say an HR employee requires access to certain services, it doesn't require access to Bitbucket, for example, right? Or your GitHub service. So the idea is to segment the network so that you provide access only to those services which are required. And then the level of access also depends on what type of user you are. Maybe somebody who is part of the technical staff has lesser privileges. Somebody who's in the admin team has higher privileges. So granular access control is also an essential requirement. And then with all these things in place, you still need to be able to continuously monitor the network, make sure that things are working as expected. There are no anomalies in the network. So monitoring, visibility, and making sure that the trust relationship which was established when the user joined the network does not get disrupted during the course of the user being part of the network. So that's where the monitoring, continuous hunting for threats becomes important. Now, within the, to address these requirements, the enterprise networks deploy multiple solutions. So no single technology, no single solution can address all these problems. So there are a wide variety of systems which are part of the enterprise security suite to address these requirements. So first and foremost, there is a collection of technologies which we call as identity and access management. I'll delve a little bit more on this in the subsequent slides. Then there is, which is basically the IAM's job is to make sure that authentication, authorization is as per the company policies, right? The job of firewall is to make sure that once the user is, admitted to the network and granted access to certain services, they only are using, the allowed services or allowed applications and so on. Then, because you have to continuously look at what is going on in the perimeter of the network, identity, basically the intrusion detection, intrusion prevention becomes an essential component of the enterprise security. And finally, as we grow into a distributed enterprise, being able to connect different parts of the enterprise, which will be physically separate, allowing users to access services remotely is also essential and mandatory. That's where the VPNs come into play. So this is some of the technologies that are important from an enterprise security point of view, and this is what is prevalent today. If you go to any enterprise, they will have a combination of these technologies deployed in their network to figure out the security posture. So going into the identity and access management part, so there is a whole lot of stuff which is part of identity access management, which is password management, user life cycle management, compliance, postures, different types of authentication mechanisms. So it is not just one single thing that is required. You need to have a full breadth of technologies which are used essentially to make sure that the right authentication mechanism is used for different types of users, different types of devices. And during the life cycle of the user, you are able to manage these identities effectively. Within the context of IAM, one particular area which is very important from enterprise point of view is what we call as network access control or NAC. The job of NAC is essentially to authenticate the user, authenticate the devices also in some cases, apply certain policies with respect to access control, and make sure that the device during the life cycle is compliant with the policies of the enterprise. So, so some of the functions that NAC performs today in a typical deployment, first, as I said, is authentication and authorization. Being able to identify that you are the user that you are claiming to be, and the device that you are connecting with is also authorized to access the network, right? That is the first part. Second is, beyond the authentication and authorization, apply certain policies to that user or that device to make sure that they are only accessing the services that they are authorized to, and being able to monitor the user and the device while it is connected to the network, and continuously checking the compliance of the device with respect to the different policies that the system may have. The policies may be in terms of as simple as you're not allowed to connect a USB to your laptop, or more sophisticated that what applications you're allowed to install, what is the software version of that application that is authorized, or mandatory checks on, what is the minimum version you should be supporting. So all that falls within the purview of what we call as network access control. So it goes beyond plain old radius authentication. There is much more which happens behind the scenes in the case of this kind of sophisticated NAC systems. So if you look at a Wi-Fi network in the enterprise, you would have a bunch of clients which will connect to the access point which are deployed in the enterprise. And these clients require internet access and also some services which are local, which are part of the local data center, which needs to be granted to these devices depending on what is their profile, what is their posture. So the question that NAT tries to, answer or ask the clients in this kind of scenario is, first of all, who are you, right? You provide some credential in terms of username or certificate or maybe something else. The first question is, who are you? What device you are connecting with, right? Is it authorized device within your system? Is it a BYOD device? Is it Android? Is it Windows? It is Mac OS, right? And then how the device has to be authenticated. I'm going to use PSK, I'm going to use WPA3, or I'm going to use certificate-based authentication. So how do you authenticate? So that's also a policy configuration within the NAC, and which parts of the network. So the where question is, where are you allowed to go? Once you are admitted, can you go access internet only? Can you access both internet or intranet? Are you only allowed to go to intranet? So these are the 4 basic questions that the NAC will ask from the device. And as part of the handshake between the device and the NAC, these questions get answered in a progressive fashion. So in the market, you will find multiple solutions which are kind of providing this kind of services. That major players in the market today would be, Cisco ICE or Identity Services Engine. From Aruba, we have a product called PeerPass Policy Manager. And then there are other players in the market, some of them which I have listed here. But effectively, all of them are trying to answer these 4 questions with respect to how the devices are managed in the network in terms of access policy, in terms of what services they can access, and what compliances they have to achieve. So starting with authentication methods, typically in the enterprise, depending on what are the use cases enterprise supporting, you would find 3 broad types of authentication flows. For employees or staff, or in case of education institution, students, you would typically use a .1x based authentication driving on WPA2 enterprise or WPA3 enterprise. For visitors who are coming to you, maybe for a meeting or for some short-term assignment, you would typically use a web authentication using a captive portal, which will be either open, or now we are also seeing OWE coming into the captive portal flows. And for machines or headless devices or IoT devices, you could rely on WPA2, WPA3. And sometimes it is coupled with MAC-based auth, where you have maintain a list of MAC addresses which are allowed to connect over PSK, so that you have an extra layer of authentication on top of WPA2 or WPA3 shared key authentication. So within this .1x authentication exchange, the players are, on one hand, you have the end user, the supplicant, the access point, which is essentially acting as a bridge between the client and the AAA server. And beyond the AAA server, some kind of identity store will be there, which will have the credentials. It could be AD, or would be some other database where these identities are stored. Then once you have authenticated the user, the next step is to make sure that the device and the user are compliant with the policy. The policies can take different forms. For example, what conditions must be met by the device for it to be called compliant? A simple condition could be that you are running the right Microsoft OS version on your laptop. And there could be more sophisticated policies. Then, in order to make sure that these policy compliance can be verified, there could be a configuration where you may need to install certain software on the end user so that this compliance check can be made. And then finally, based on the type of user or type of role of the user, the policy can dictate what you are allowed to do within this network. Then the Wi-Fi access point here becomes a policy enforcement point, because all the data is flowing through the Wi-Fi access point. So that's a natural place where you can start enforcing those policies in terms of what is allowed and what is not allowed from a network access point of view. And then finally, for compliance check, typically there are agents which are installed on the endpoint, which will provide the details about what softwares are running, what version of software is running, what is missing, what is there, so that the NAC can figure out whether this device is compliant or not, and then take subsequent action on that. So, what action can be taken is what we call as dynamic authorization, which is essentially after you have completed the authentication and you have figured out what is the posture of the device, you decide how you want to treat this device. Now, there are two ways typically where people will enforce this. One is you can have different VLANs. So once authentication is complete, you may put, one type of user is in VLAN X, another type of user in VLAN Y. Right? For example, if a user is authenticated successfully, but we find out that certain software on that device is not as per company policy, then you will put in something what we call as a quarantine VLAN. Until you correct your posture, you will not be put in the correct your default VLAN. Other way to do it is that you apply certain ACLs or access control rules on the Wi-Fi access point itself to make sure that depending on what type of user is it, what network subnets they are allowed to do, what services they are allowed to access. So these two are the different mechanisms by which you can achieve this kind of dynamic authorization so that you enforce the policies on the endpoints after they have done the authentication. And as we have continuous compliance checks, your authorization will change. That's why we call it dynamic authorization. So since the system is doing periodic reassessment, then after if the reassessment fails, then you put the user back in the other VLAN where they are allowed only limited access. So this is a simple call flow, simplified, I would say, call flow that you would see in an enterprise scenario where going beyond .1x authentication, the system tries to figure out what is the posture or the compliance status of the device. And then based on that, it tries to assign the right VLAN or right ACL to that user. And that's how we are able to segment the access based on the user role or user profile or type, device type, all kinds of policies can be built on top of this kind of flow. The other call flow that is very common is, as I said, for guest users, you would typically use a captive portal. So I connect, I get a web page where I, enter some details like I'm email, phone number, I will get an OTP possibly, and then I get access. So their objective is primarily to provide short-term access to internet to such users. Because such users are not going to access the intranet resources. So the call flows are simpler, but here also we see in the market that there are various variations of this call flow. Some people want, simple, you just provide your credentials, you are allowed access. In some companies, customers are asking that I should get an email and then I will click on something and then user will get access. So depending on the use cases, there are various, call flows that are supported within the captive portal or web auth system also. So, and because a lot of this is proprietary, it's also a challenge for AP vendors to support these kind of call flows. .1x is simple because it's radius-based call flow and everybody understands it. But captive portals are a huge challenge both from implementation point of view because the handshake itself is very proprietary, and then customers keep asking for all kinds of different fields that need to be supported under the captive portal flows. So finally, to summarize, as I said, security is really, really important for enterprises, mainly because it has a financial cost. If there's a breach, it will typically have a financial cost in terms of either loss of data or loss of service or loss of customer trust. And the way we look at it from a solution point of view is that there is a bouquet of services or security services that are available, and enterprises deploy these services to solve different problems using different solutions. But the important part here is that it requires continuous monitoring. It's not just about, WPA2, WPA3, handshake is done and you are done. There's a lot more which goes behind the scenes where you are continuously evaluating these devices and figuring out who is behaving, who is not behaving, and taking appropriate action so that the threats can be minimized. Thank you.
And Nadeem, a quick check guest access. How important is open roaming for enterprise? And if no, why are they not deploying open roaming? And does NAC introduce challenges for the client device side?
So I think in guest access, typically the captive portals have done a good job. It's a very simple flow, in the sense that you can have something as simple as just give a user a web page, they enter their personal details, and you allow them to go through. Doesn't require any sophisticated handling. Uh, with open roaming, the challenge that we are seeing is that two things. One is for reasons, good reasons, open roaming mandates that you use RADSEC. Instead of using plain radius, all the communication for open roaming has to go over RADSEC, which means two things. Either every AP should be able to establish a RADSEC connection from the AP to the AAA server, or you put some RADSEC proxy somewhere and then RADSEC proxy takes care of establishing a RADSEC connection. In both cases, we find that there are challenges with respect to how scalable that solution can be. Certificate management on APs is non-trivial, and that puts additional cost on both the enterprises as well as the AP vendors. So enterprises, I'm not seeing a lot of uptake on open roaming, primarily because of this certificate-based, enforcement and then requirement for RADSEC support. I see more AP vendors are now starting to support RADSEC, so things might change in that direction. I think what was your second question? I forgot. Client, yes. So yes, so this is a good question. I think both APs and clients. So Wi-Fi Alliance will only specifying what happens on the air interface, but between the AP and the AAA server or the NAC, it is radius. But beyond that, between the client and the NAC also, the NAC vendors have developed agents or softwares which need to be installed on the clients in order to communicate with the NAC, because there's no standard interface between the client and the NAC. So this is all proprietary implementation. So this has two meanings, right? One is whatever agent vendors are developing has to work on Windows, Linux, Mac OS, everywhere, because enterprises choose whatever they based on their requirements. Second is from the access point of view. Some of this handshake, even though it is happening between the client and the NAC, in between the access point is sitting, and certain actions access point also has to take based on what is coming from the NAC in order to intercept the traffic and apply certain rules. So it has impact on both sides. I think client side, because enterprises typically use well-known operating systems, so the agents are available, and some of these agents are actually like short-lived agents. You download it, they do the job, and they are deleted. In some cases, they are like permanently deployed. So there are various ways to do this, but of course, there is an impact on the client side. But AP also needs to do a little bit more than just plain .1x for this kind of flows.
Yeah, last question.
So thanks for teaching us the security posture, broad-based access, and segregation of the duties. So my question is, what is your thought on the Wi-Fi devices, basically the access point and the client, should have a basic criteria or a certain criteria for the manufacturers to support on the security postures on implementing the NAC. So basically for the credit cards and everything, we have PCI DSS standard, and for the personal information, we have GDPR. So on what basis should consider having a minimal or a certain criteria on implementing these?
If you look at how Wi-Fi Alliance looks at it, Wi-Fi Alliance certifies the APs in terms of they should be able to support WPA2, WPA3, OWE, all the standard mechanisms which are mandatory for both home Wi-Fi or enterprise Wi-Fi. So that is one part which is part of the certification scope today as part of WFA. But beyond that, because the story doesn't stop here, right? Even if for WPA3 enterprise, you will need to talk to a AAA server, which requires the radius client on your access point. Those are typically left to implementation on the AP side. But most APs today will have a radius client. So being able to complete the full .1x authentication is what every AP vendor would do today. I don't think it really requires certification. That becomes like a minimum requirement for most vendors today.